Well, good morning from Hamburg and welcome to JCON-ONLINE 2022. Thanks for joining my session about simply good tests. Simply good tests, what a claim. A huge claim, what are good tests? But as the session is for newcomers or for beginners, we cover the basics, the foundation, which make good tests in the end, which you'll need for good tests. So let's have a look what this is all about. This is me. I'm a technical agile coach working for Die Techniker, TK, which is Germany's largest public health insurance company. And as a technical agile coach, I go to our teams, work with them, and together we'll see what next little step can help them to improve their way of modern software engineering. That means we'll cover aspects of agility and continuous everything, of architecture and architecture for testability, and of coding and testing as well. And when it comes to coding and testing, I noticed some patterns, some things that are good to know for everybody in software development, and that's what I want to show you today. So what we're going to see today. I'll give you a brief introduction of the subject with only a couple of slides, I think 5 or 6 slides. Then I'll do about half an hour of live coding. And in the end, we'll have a short roundup and a Q&A session. I'll have a look at the chat. So maybe if you put your questions in there, I can answer them in between, or we'll have a look at them together at the end. Why this session? It's about beginners and tradition. Why beginners? We've got lots of newcomers to our industry. Every year, more and more software developers join our industry, develop software, and have to automatically test it. Then we've got lots of career changes. I've met a few people who worked in entirely different jobs a few years ago and who said, oh, IT is cool, software development is cool, so let's go there. And we've got returnees to the job. For example, after raising children, you return after years being a software developer, and it feels like a beginner, a newcomer again. And there's a lot of tradition. Tradition is what we've always done this way, and we're doing this just because. And that's not necessarily bad. It's just you have to understand why you're doing this. And tradition is often copy and paste. A copy and paste tradition. And I cannot see many of you if you're smiling, because I always have to smile if I do copy and paste software development, but that's okay. We all do copy and paste software development. It's just important to understand what we're copying and if we're using it the right way for our context. Because if you don't understand what you're doing, it becomes a cargo cult. This means you're just doing something, you're just copying something that you see in your code base. And if you don't understand what you're copying and pasting, you cannot adapt it to your needs. And this would be a really bad tradition. So this session is about the basics, about the good practices of writing good tests, good structured tests, good name tests. Yeah, what are good tests? We all have different notions about good tests. And if we manage to write a test that runs, that is green, we're really happy or maybe even proud that we got this test running. Or we really like the little trick we had to use to make it running, or it was a wicked hack to get this running. And maybe it was too hacky, so we rather weep what we had to do to get this test up and running. And sometimes it makes our head explode. So there are different ideas about good tests. And it's hard to get to say these are good tests. So maybe let's start with a different way. Why shouldn't we write good tests? Well, let's see it from a developer's perspective. Maybe we say, oh, they're not maintainable anyway. I've seen so many of them. The code is crap. I can't maintain them. Why write them anyway? They're not readable. or they're always broken, they're flaky, or they're too slow. If I write my tests and run them, they need minutes or many minutes before they're finished, or even hours. Those tests probably don't make much sense, and they are not fun to write. Then there's our bosses. Maybe they've heard something about test coverage at a conference, and they just aim for high code coverage, which isn't a good goal, actually. Or they're just they are the traditional managers that say so much quality costs too much, testing costs too much. They have to pay for it. Maybe they even know it, but then later on, maybe we should build that quality in, because you cannot inspect quality. You cannot inspect quality into your product later on. And then there's us developers and our bosses. And we're always talking about, we don't have time for this. We've got so many features to build. Why should we write tests? And once we missed writing the tests, we've got many tests to write afterwards. And retesting is a pretty stupid activity. I don't like writing tests for a system that hasn't been tested thoroughly. And it's pretty expensive if you test afterwards. So then, how to test? If we think, maybe it might be a good idea to test, how to test then? And if you're at a conference and there's something with agile or continuous in it, TDD, test-driven development, comes to mind. When I was younger, it was called test-driven design and development, to put an emphasis on the design aspect of TDD, because TDD is no testing strategy. TDD is a code design technique. So it helps you to improve your code, to get a better design, to get a better testable design, but it's no testing strategy. It might yield some tests in the end, with a cycle of, maybe you've heard red, green, refactor, and that means write a test, write the implementation, and then refactor or redesign your code, that it's better readable, better maintainable, better testable, once you understood what your domain is all about. Maybe if you don't do TDD, you at least try to do test first, or maybe test soon enough. And everything that you do about testing is absolutely okay. But it's definitely not writing all tests up front. I've seen projects where they try to implement all tests at the beginning of the project, and that doesn't make sense, because we learn while we write tests in little steps, and we adapt them step by step with every little piece that we learn about our domain. I'd like to call them accompanying tests, tests that we write together with our implementation, maybe using TDD, maybe using test first, but always together with our implementation, step by step with small experiments. That's what our tests are, our micro tests, and maybe in the end they will yield some safety net for automated fast unit tests. And probably you know, or maybe you know, the classic test pyramid. Meanwhile, there are lots of different test pyramids. They even don't look like pyramids anymore, but the basic ideas are still the same. The idea is to have a lot of fast tests at the base, and then fewer integration tests, and then only very few end-to-end tests. And of course, we will need some manual exploratory tests, but the idea is to have a huge base of fast tests, which we call usually unit tests, and during design, we call them micro tests. They serve different purposes. The classic test pyramid shows us how many tests to write, and they shows us the execution time, because usually the higher we get, the slower the tests are. And the higher we get, the less stable our tests are. And the question is, on all levels of those test pyramid, do we have some common ideas and good practices? And we'll have a look here at the bottom of the pyramid, but the ideas we'll see, I think you can make use on all levels. So let's try to write some tests, and let's have a look at some requirements which we are about to implement. And that's a sushi service. With a sushi service, a customer can order a menu. The service returns an order number, which is an 8-digit number starting with a 1. Fair enough, seems simple. And ordering a la carte is out of scope for this task. All right, so then let's go into the live demo and see what we can build. This is too small. So this is better, yes. All right, this is just an empty project as we'll cover the basics. And let's just create our sushi domain. And the requirements were we'll have a sushi service, right? So let's create a class, sushi service. Now, what am I gonna implement? Like order meal, or maybe order menu, or, well, order dish of the day or something like this. And this is something that you have to talk about with your business people, with your product owner. And I find it pretty hard to start with the implementation because I'm very fast biased towards the implementation. So maybe let's not start with the implementation, but with the use of this service. And I'll do this in a test. Let's put this in the sushi test. And this is a JUnit 5 test. This is fine. And let's just create a test for JUnit 5. Yeah, name is okay for the time being. All right. Now, what are we going to test? Now let's make a wish. The code isn't even there, but let's make a wish and try how our sushi service might feel if we call it. So we've got our sushi service. Sushi service. And I've talked to my business people, to my product owner, and she said, yeah, let's order a menu. And the menu is a menu name, maybe. And the sushi service returns an order number. And let's say this is just a long. All right. Now we see how we're going to use it. And this is a failing test. Don't believe me? Let's run it. And maybe you didn't notice, but we start the test first. And this test doesn't even compile. It's red. It's failing. This is a failure, right? Now we can implement this sushi service and make this test green, but it's a failing test. We started with a failing test. All right. Now, ideally, we'll start not with the thing we like to call, but with the assertions. What is our test about to test? But sometimes it's easier, like we did here, to start with a thing we'd like to call. But now let's go with the assertions. Assert true. If I've got an order number greater than or equal, it was an 8-digit number, 1, 2, 3, 1, 2, 3, 4. And I'd like to be the order number below 1, 2, 3, 1, 2, 3, 4. So these are my assertions for a valid order number. So I can call this test, say, test order number, order menu. Order menu is successful or something like this. Yeah, it returns a valid order number. So let's call this test order menu successful. And this isn't a name I'd like finally to commit, but it's good enough for now, and we'll improve this step by step. Now we can implement what's missing. And this is kind of still test first. And now have a look at the parameters. It's not a menu name. The requirement said the customer can order a menu. So maybe I need a customer here and a menu. All right, and now let's create everything that's missing. All right, I'd like a local variable, and the IDE doesn't know that this is the sushi service, but I can help here, and I can create An empty sushi service. Yep, that's okay. Now I need the customer. Oh, no, it imported something which I didn't want to have. I like the customer. The customer is some customer here. On the menu, I don't want to import AWT. That's so 90s. Let's create a local variable and make it our own menu. All right. And now I can create those classes. And we're still test first. We're only creating the things that we need, guided by our API, guided by the usage. So I create our customer, not in the test package, but in the main package. Yes. That's okay for now. It can stay empty. All right, back to the test. I can create the menu. And I think it just imported this. I don't know why it is doing this today. All right, then let's just create a class here. It can stay empty. That's okay. And it will import this. So we're almost done. I need some empty objects here. All right, and now I can create this order menu. There we are. I think the parameters are all fine. And let's return, let's return along here. Now, that's it. That's our first implementation, and see if the test runs. Please excuse me for using only Java 18 here. Java 19 will come out later today, but I didn't dare to use a pre-release version, so I'm still on Java 18. I hope that's okay. So the test fails. I expected true, but the actual is false. Click to see the difference. Yeah, will do. And oh, yeah, true is not false. That doesn't help me much. All right, now what we're going to do. I'd like to replace these assertions with better assertions. And maybe you know something like Hemcrest or assert_j. I'll be using assert_j here. And that's assert that. And assert that is a method from, I won't use Hemcrest, as I said. I'd like to use the assert_j core. And now I can say assert that order number is greater than or equal to, and then I'll take the lower range, the lower bound. And then I say I assert that the order number is less than or equal to the upper bound. All right, let me just comment out these two lines. Before I'm committing, I should delete them, but we'll have them for comparison here. And now if I run my test, I get better output for my assertions. It says the actual 0 should be greater than 10 million. So that's a much better error output of failure message that helps me maintaining my tests. All right. Now, do we know something more about our test name? Test order menu is successful. That's pretty old. That's pretty much boilerplate code. We won't need the test anymore. That's from JUnit 3. We're on JUnit 5. So let's just call it order menu is successful, or something. Maybe you know this pattern. Order menu should return a valid order number, something like this. Just valid order number. All right. So that's a better name. Improve this step by step. All right, now we'll need some fields in the custom and the menu. Let me put some fields here. And this is a private long ID, string name. I'll need a getter, get ID, and oops, sorry. And maybe a setter. And the same for the name. All right, I could have generated them differently, but I think it works this way too. And for the menu, I'll put here a private string name. And I'll have the same of get name and set name. There we are. Now I can use this. I can put the customer here and say customer set ID 1234. That's a brilliant ID, isn't it? Customer set name, that's me. And now the menu set name, that's a Maki. I really like Maki sushi, so let's make it a Maki menu. And now I think the test is still failing. We should make it passing, right? Yeah, let's make it passing. I just comment out the things that we've seen so far. So let's just make this 10 million, and then the test should be green. Yeah, finally. All right. Now we've got a complete test that's green. And as you see the setup here, you'll find lots of tests like this way. And when you need the setup more than once, it's pretty common to extract this into kind of a setup method. So I'll make a field out of this variable. You see it's created a field here. And I'll make a field from the, I'll make a field here. Yep. And I'll make a field here. So we've got two fields, and we'll just populate the fields here. Now we can extract this into a method. It's called extracted. Usually I wouldn't call this extracted, but just setup. And then we could call this like before this was JUnit 4. JUnit 5 calls it before each method. And I have to remove the private to make it running. And then I won't have to call it. It will be called automatically by JUnit. And it's a matter of choice if we put it at the top or at the bottom of the class. Let me just leave it at the bottom for the time being. Now we've got a test which contains only the thing that we're testing and the assertions. All right. I've got a problem with this because I can't see what the test is really testing. I can't see the test data here. And that's why I really, I'm really cautious about using too much of the setup in the before methods. I'd like an explicit setup in my methods. And let's do this. And maybe, let's get rid of the before each method again, and let's make the setup more explicit that we see in each method what we're doing. And I'd like to introduce something, maybe some factory methods. So before each will go, let me duplicate this method. We'll need it twice. And let's just call it test customer. We'll create the customer here. And then we'll return the customer. All right. Now it says, oh, it doesn't return anything. So make it return the customer. Yeah, it's changed that. And we've got the test menu. We don't need the customer here. I've got the menu. And I return the menu. And again, it says, oh, please let the method return the menu. And now I won't need the fields anymore. And I can, like before, have a customer here. And now I say that's the test customer. And I've got a menu here, and that's the test menu. And now I've got an explicit setup in each test where I see what this test is about to test. And now test customer is a pretty common name. Maybe we call this this is our default customer. Well, maybe you created some personas, and the persona said, oh, that's our default customer without any special attributes. And this test menu, this may be my marquee menu. So I see in my test setup what I'm going to test. And maybe you've got different tests where you have say, underage customer. What will your code do with an underage customer or with a dish of the day? So you can see in your test setup what this test will actually test. Often I like this pattern better than putting too much into the before method. And if you've got lots of these factory methods, you probably are tempted to extract them to some, let's say, a customer test data class or menu test data class. And this is called the object mother pattern, where you've got one class that can create all our test customers, one class which can create all our test menus. And this can be helpful, but you have to take care that these classes don't grow too much. And maybe if you want to know more about this, you could use this object mother pattern, or maybe even better, a test data builder. This is a customer data builder which can create the customer, and you can even combine this together, that you have a test data builder which creates your customer and some predefined customers like the object mother pattern. So if you like this pattern and you want to have some keywords to search Google or any other search engine, try to search for object mother or test data builders. All right. Now we've got a nice little test that tests everything. And let's see if we know some more about our test name. Order menu should return a valid order number. I think there's some boilerplate in it, because order menu should return. Now, if it runs successfully, it just returns this. Order menu returns valid order number. Now, that's the name, isn't it? The only thing, if I try to report this to my product owner, there's a lot of camel case, and that's hard to read. So I could put some underscores in here, returns valid order number. And if you say, oh, that's not a good style for Java code. No, in our main code, I wouldn't use underscores, but it's absolutely a common practice to have different coding rules for tests. And using underscores is one of those possible rules which you might find for your team. Now, it's better readable, but in a report, it still has those ugly underscores there. Let's get rid of them. Maybe you know JUnit 5, and we've got the display name. So I could just copy this name and put in spaces here. So I've got complete sentences. But as you can see, it's the same as the method name. So I duplicate some code here, but we got a nice little output, better readable than before. So I really like this way of naming my methods, but I don't like to have a display name on top of every method. And this is where the display name generator comes handy. This is JUnit 5. And the display name generation can use a display name generator. And I use the replace underscores generator. This is a built-in generator. You can build your own, but I like the built-in generator. Often that's already enough. And if I use replace underscores, it will do exactly the same as before. And I've got good readable method names that have a meaningful name, a meaningful name to our business owners, to our product owners, maybe even. All right. Why is that important? You may have noticed that I talked so much about tests and improving the test names. Well, tests are part or should be part of our documentation and specification of a product. They are living documentation. If we write those tests, like you've seen here, they're part of an executable specification, and we should really take care of the names that they fit the purpose, what you're testing here. And as you've seen, it's not important to start perfectly. We can't do this. We can't start perfectly, but to improve, to get those names better and better. All right, time for a bug, right? We're doing this testing to catch bugs. So let's introduce a bug. It's early in the morning, say, I haven't slept well, and I have to implement something in the sushi service. Let's duplicate this. And for some unknown reason, I'll return the customer ID here. Oops, a bug. Yeah, don't know why I should do this. Let's run the test. And as you might expect, it fails. It says a customer ID, which we initialized with 1234, isn't greater than 10 million. So it catches the bug. But now imagine your company merges with another company, and all your customer data are moved to a different range. So let's say it's not 1234, but it's about 12 million. And now your test will pass and you don't catch the bug. It's a real logical bug, but your tests don't catch it anymore because it's unfortunately the same number range. What we are going to do about this, and this will have to do something with testing. Now I return the long here, and returning a long isn't probably a good idea. What would be better? Let's start with a test again. Yeah, longs are just nothing. You can interpret them any way you like. So let's not expect a long here, but an order number. Some value object that contains everything we need to know about order numbers. Create a class order number in the main package. And this order number is, as I said, a value object. This is an idea that's heavily used in domain-driven design. We've got our types, our domain types within our code. And I think I'll need 8 digits here. Digits. I'll need a constructor. I'll need a getter. But I'd like to use a cooler way of naming my getters. I wouldn't use this as a Java bean, so I call the accessor just like the field. This is a modern way of naming things. What do I need for a value type? I need this field to be final. It should be immutable. Then I will need equals and hash code. Yeah, Java 7 is okay. We're in Java 18. Yep. And I will need toString. That's everything we usually have in a value type, just to contain these 8 digits number here. All right, now I can use this. So the order number will be returned, and then I cannot say order number is greater than, but order number 8 digits is greater than or equal to. Remember, we want to have readable code. I think this is pretty readable. Now what's missing is our order menu doesn't return an order number, so we just make it return an order number. Let's have a look if that worked. I want to go to the implementation. So this works. Only we have to return not a long, but the order number. So now I can say new order number. And I still can make this bug, but if I say return new order number with a customer ID, I might get an idea that this is an actual bug. So let's just return our old number here, 1, 2, 3, 4. All right. Comment this out. Okay. Okay, and now we've got our value type inside our domain code, and this is part of our static testing that are compiler checks for us, and we don't have to test this using dynamic unit tests. This is an important aspect of testing, the static testing. Now let's see if what happens if an order number is returned here, if we return the wrong thing. Yeah, it still catches the bug, but it would be even better if our order number would have this check here, say, let's put it here, if 8 digits is less than 1, 2, 3, 1, 2, 3, 4, or 8 digits is larger than 1, 2, 3, 1, 2, 3, 4, then I'd like to have throw new illegal argument exception, wrong order number, something like this. And now, if I run this, the value type checks itself. I don't get to the assertions, but the value types checks itself. And now I can return to my test. So the order number knows if it's a valid order number. So now I just need to assert that the order number is not null, because everything else, the value type checks itself. Now this makes a smaller and even more readable test. Yeah, and now I can make this test pass again. Let's just return 1, 2, 3, 4, a valid order number here. And we're almost done. Now let's do some final refactoring. And I don't know if you know Java records since Java 16, because these value types are really, really important for static testing, even below unit testing. But it's pretty tedious to write those final classes like this. So I'd like to make a Java record out of this. And records work this way that they get the fields inside this constructor. I won't need them anymore. Records automatically get accessors the way I named them already. They've got equals and hash code out of the box, and also to string. So everything we did for the value type, for the static testing with value types, we get out of the box with records. And we're using the canonical constructor here, which takes all the parameters, assigns them and can check them. But I want to have all the parameters assigned to the internal fields, so I can even make a compact constructor out of this, and I don't need to assign the fields. So this is the smallest implementation, I think, of a value type in modern Java. And you can put them everywhere in your code. Put your domain language into your code to make your tests readable. All right. Now, what did we see? We wrote our test, our small and readable test, and we started with something that I'd like to call the when part, or the act part of your test. And then we've got this then part here. So we used a structure in your test, and that's based upon arrange, act, assert, or given, when, then. And this above here is the given part, or the arrange part. And this structure helps me to get my tests concise, to make them test one thing, and to assert as few things as possible within this test. But this way of thinking, this way of structuring helps me to test exactly one thing in this test. And given, when, then comes from behavior-driven development, BDD, but we can use it in our unit tests as well. Some like to call it arrange, act, assert, whatever you call it. Actually, I don't care, but it just helps to think in this structure to get your tests readable. All right, that's it for the live coding. Now some quick recap on the slides, and then we'll have some time for Q&A. Now, understandable, maintainable tests. This is, of course, a subjective thing. This is my opinion, some good practices that we found helpful in some contexts, in some teams. But these things might help you too. Every test method should test one thing, at least at the lower stages of the test pyramid. And given when then our range actor cert helps you structuring them. Please prefer an explicit setup. Don't use magic, implicit magic. It helps you read your tests later on. And don't try to start too perfect. Better improve little by little. There's the saying, make it work, make it beautiful. Start by getting it work, then make it more beautiful and improve step by step. Let's have a look at the test pyramid again. We've seen many common ideas. Everything we saw so far, you can use on all the levels of the testing pyramid, even if it doesn't look anymore like a pyramid in your case, maybe. And we've seen the compiler type checks. We're using strict statically typed languages like Java or Kotlin, and this is static testing that our compiler does for us. And everything that's tested, that's checked statically, we don't have to test dynamically. And this is even faster than the unit tests. So use your compiler type checks, use static testing, use all the aspects of modern Java or the modern parts of your language that you're using. And please use your domain language, the ubiquitous language within all your code base and also in your tests. Now, this boils down to write boring code, even in your tests. And boring doesn't mean stupid. They're surely clean, or let's call it tidy. Optimize your code for reading without setup magic and without surprises. And this helps you that you can understand and read your tests in 6 weeks or 6 months or 6 years from now. And if you think this is helpful for you, you might want to read some good books. There are some pretty new ones like Agile Technical Practices Distilled or Effective Software Testing from this year. And they help you understand all the levels of the test pyramid and have a deep dive into unit testing as well and micro testing. And there's a pretty old book, Growing Software Guided by Tests. The object-oriented comes in because this book is 12 years old, I think, but we can just call it Growing Software Guided by Tests. And this book helps you to understand of why you should have fast tests and how to write them. And these books even help you going further. We've seen just the basics of fast tests, and these books help you to go further, not just for the structure and the naming, but also for the design of testable architecture patterns that you probably should use in your code base. Now, 5 minutes left for your questions. I hope you enjoyed it so far. Let's see if there are any questions. Okay, there are some questions. Let me just see them. All right. What is my opinion on as a helper method for descriptions? Let's go to the code. And here's a description. If it helps you, use it. It doesn't make sense if you've got too many assertions, but I don't like to have too many assertions anyway. So if you've got 1 or 2 assertions and you can describe in a short sentence why it should not be null, because if we've got an order number, it's valid. Use this description if it helps, if this description helps you more than the failure message of the assertion. I think you get an idea if you use it a little bit, if you need this description, but it's helpful for you if you can provide more context. Yeah, please do so. Can I elaborate on object mother? Object mother is a pattern that says, oh, now if I create the customer here, and this is the default customer, and then I've got an underage customer, and I have to set not only 2 things, but I have to set, say, 10 or 12 fields or 20 fields. This can become really tedious. So one is tempted to extract those setups to this creation of different customers into one class. And if it's not just a test util class, but a customer test util class, we can put all the customers, all the creations for the customers in one class, the customer test utils class or customer test data class. And this is called an object mother that knows everything about customers for all contexts. And this makes it, the mother of everything, because it knows all the customers that you will ever need. And this will become more and more complex. So it's okay to start this way, but if it becomes bigger and bigger, it might be easier to create the customers not in one place, but in different places. And this is where the test data builder comes in handy, where you can say, create customer with this, with that. And if you combine this with, say, test data builder, create default customer with a different ID or with a different name, you can combine the test data builder with some predefined creations for your customer. So you don't have one thing, one place where all the customers are created, but you can have them created as some base data, but then you can adapt them to your needs. Does it make sense? Okay, hope so. Yeah, great question. Shouldn't we add a test to check if the order number is wrong? Yes. I did this presentation before, and I managed to build in a bug, build a bug in here. So of course I should have done this test driven, and I should have created a test for the order number first and see if the exception comes in the right thing. So if the digits are too small or too high, you're absolutely right, and I just omitted the test to get through the story. But you're absolutely right. We should have written a test for the order number first. Yeah, thanks for pointing this out. And this may be the last one. How do we measure test code coverage? There are tools for measuring code coverage, but if you have cast like Eclemma or JCON-ONLINE, but if you use code coverage as a goal, say we want to achieve 90% code coverage, you will test things that are fragile and that don't help you. So better aim for lots of fast tests and you will get code coverage, by the way. So, time's over.